The first three terms of a geometric sequence are integers a, 720 and b, where a is less than 720 and 720 is less than b. What is the sum of the digits of the least possible value of b? Note that both a and b are integers. Also that a is less than 720 and 720 is also less than b. Not a is equal to 720 or less than 720. Similarly, 720 has to be less than b, not equal to b. For a geometric sequence, the terms are a, ar, and ar squared. Therefore, ar is equal to the second term, that is 720, and ar squared, that is the third term, that is equal to 720r, and which is b. In other words, 720 is equal to the square root of a multiplied by b. By analyzing the sequence, we come to the following conclusions. It is specified that a and b are integers, but nothing is said about r. So r could be a non-integer. Second conclusion that we draw is r is not 0, because that would make the second term, that is equal to ar, is equal to 0. But we know that the second term is 720. Therefore, r is not 0. The third conclusion is r cannot be negative, because then b is equal to 720 multiplied by r will also become negative. If that happens, then 720 will become greater than b. This violates the specification that 720 is less than b. The fourth conclusion is r cannot be between 0 and 1. That means it could be positive, but still not less than 1, because then the condition that 720 is less than b will not be satisfied. Or 720 is less than r into 720 will not be satisfied. So r has to be positive but greater than. Before going any further, please like, subscribe, share, and hit the bell so that you will be immediately notified about new videos. It takes only a few seconds, and you can always unsubscribe later. And it is completely free. Without further ado, let's proceed with the problem. Continue with the conclusions that we can draw from the conditions given in the question. Because 720 is square root of a multiplied by b, both a and b will have to be simultaneously positive or simultaneously negative. Suppose a is negative, then the middle term 720 will be positive only if r is also negative. However, as discussed, r cannot be negative. Therefore, a or b cannot be negative. Hence, both a and b will have to be positive. Now, to solve the problem, we have to find the least possible value of B. The least possible value of B. This means that we first have to find a value of R which is greater than 1 and which results in a positive integral values for both A, that is equal to 700 by R, and B, that is equal to 720 R. Moreover, R has to be the least so that B, that is 720 into R, will also be. Now, the prime factors of 720 are 2 multiplied by 2 4 times, 3 multiplied by 3 2 times, and 5. Let us consider some possible values of R within the constraints discussed earlier. Let us first consider R is equal to 1.25. Then A is equal to 720 by R, that is 720 by 1.25, that is equal to 576. And B, that is equal to 720 multiplied by R, or 720 multiplied by 1.25, that is 900. Or a even better result comes from R is equal to 1.2, so that A is equal to 720 divided by 1.2, that is 600, and B is equal to 700 multiplied by 1.2, that is equal to 840. A still smaller R is 10 by 9. Then A is 720 multiplied by 9 divided by 10, that is equal to 648, and B is equal to 720 multiplied by 10 by 9, that is equal to 800. But the best value or the least value of R is 16 by 15. In that case, A becomes 720 multiplied by 15 divided by 16, and that is equal to 45 into 15, and that is 675. And B becomes 720 multiplied by 16 divided by 15, and that becomes 48 multiplied by 16, and that is 768. Check that out of the values of B found out, 900, 840, 800, and 768. 768 is the least value. Now, I have to emphasize that this appears to be the least value of B. I have not proved here that 768 is the least value of B. I have only taken some possible values of B and I have found out the least amongst those. And I have not been found out any other value of R which could result in a smaller value of B. If you know how to prove this result without a computer, please let me know. Now, if 768 is the least possible value of B, then the sum of its digits are 7 plus 6 plus 8, and that is equal to 21, and that is